Okay, success criteria 5 looks at finding the key points of a polynomial. So my advice to you people is to graph it and then see exactly what the story is. Now, the polynomial can be x squared, can be x cubed, x to the power of 4, x to the power of 5, x to the power of 1, whatever the case may be. They're your polynomials where x is a positive, power is a positive value of 1 or greater and it's an integer. So, based on that, that's what we're looking at. So what we're going to try and do, we're going to say the key features of our parabolas. So it's power 2, we'll have, and I'll just do this one quickly. So you're going to have a turning point, we're going to have x-intercepts, and we're going to have a y-intercept. They will always have a y-intercept, always have a y-intercept, and it will always have a turning point. They won't necessarily have x-intercepts, depending on what you're asked. But if it's a polynomial, it will always have a y-intercept unless the domain is restricted like here. So let's have a look at this. So this is what we've got. We've got x squared minus x minus 6. So what we want to do there, we want to factorise that because we want to find the y-intercept because it's the easiest thing to find. So we'll say let x equal 0. So we end up with y equals negative 6. So that is our y-intercept. For our x-intercept, we let y equal 0. And so we've got x squared minus x minus 6 equals 0. And then we'll factor this. So this will end up becoming x minus 3, x plus 2 equals 0. So our x-intercepts happen at x equals 3 and negative 2. So there are our x-intercepts. Now, parabola being symmetrical, we know that our turning point is halfway between these. So if I'm going from, so I'm here at negative 6 as my y-intercept, negative 3, and then I'm going out to 2. Well, I know that I've travelled 5. Going from negative 3 out here to 2, we've got a distance of 5. So half of that will be 2.5. So we go negative 3, we're going this way, 2.5. We go back 2.5, and we are at negative 1 over 2. So then we've got our x coordinate for our turning point. We substitute that back into our equation. So we'll have negative 1 over 2 squared minus 1 over 2 minus 6, and we get our y coordinate for our turning point. Okay, now sometimes you may be given something like this where it's in function, formal function, mapping, notation, whatever. In this case, what they're telling you is they're restricting the domain to 1 and 4. So some things may not happen. So what we'll do, we'll have a look, we'll see if the x-intercept, the y-intercept are in there, and then we'll go from there. Now this is a cubic. The other thing a cubic will have, it won't have necessarily have turning points, it may have a point of inflection. So that's what this thing's going to have, but we'll have a look at that. So with this, so I know that this, because I've drawn these a million times, is going to look something like that, and it's going to intersect there at 2. Okay, so with this, I'm going to find the x-intercept, so I'm going to let y equal 0. So I'm going to say that x cubed plus 2 equals 0. So therefore x cubed equals negative 2. So then x equals the cubed root of negative 2. So that's it, that's it, cube root negative 2. Then in terms of the y-intercept, I'll let x equal 0. And we've got a y-intercept of 2. Now, from there, I will redraw this set of axes. Now we've got a bit of a problem in that the graph goes from 1 to 4. It doesn't start at x equals 0, and it doesn't have, so we don't have any x-intercepts. We don't have any y-intercepts, and we don't have any x-intercepts because it's here at a negative value. So what we do with this graph, we're going to have to include these endpoints here. So I'm at 1, so I'm going to say 1 cubed plus 2 equals 3, and I'm going to say 4 cubed plus 2 equals 66. So my graph will look something like this, where I'll then mark my points at 1 and 3, and then over here at, I know this one has to be open, at 4 and 66. So that's the key, labeling the key features. If endpoints are not specified, like in this, we're not restricting our domain, well then we can't name any endpoints at all. We just go find x-intercept, y-intercept, turning point. If our domain is restricted, well then we still have to check to determine where the x and y intercepts are. If they are a part of it, well then we've got to say there's one at whatever it may be. But if not, well then we just have to indicate that we've got no x-intercepts, no y-intercepts, but we do have 2 endpoints and what they look like. So that's your key features of your polynomials.